Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 25 to 29 of the Algebra 2 Common Core New York Regents exam for January 2017. All right, let's take a look at question number 25. It reads, express 1 plus I to the third in a plus bi form. So one thing you want to recall concerning I is that if I has a power that's greater than 1, it has to be reduced. Okay? How do we go about reducing powers of I that's greater than 1? So let's recollect the following facts. Reducing powers of I. Now, if you have I, that's okay. Alright, you don't have to do anything. But when you have I raised to the second power, this has to be reduced to negative 1. I to the third power has to be reduced to the product of these two, which is negative I. And then I to the fourth power has to be reduced to I squared times I squared, which is 1. Now the cycle repeats itself, okay? So I is equal to I to the fifth. And then this is equal to I to the sixth. This is equal to I to the seventh. And this is equal to I to the eighth. Alright? So if you have powers of I that are greater than 1, you just have to figure out where they fall in, either in I, negative 1, negative I, or 1. And all you have to do is divide the power by 4, whatever the remainder is. That's exactly where you fall in. Okay? Now let's go ahead and solve the problem. We have 1 minus I raised to the third power. So using our properties of exponents, we know that raising this quantity to the third power means that we are going to multiply this quantity by itself 3 times. Okay? So when we're multiplying, we're going to do the first two first. Let's multiply 1 minus I and 1 minus I. Okay? So we're going to FOIL that out. We're going to do first, outer, inner, and then last. So let's multiply that out. We have 1 times 1. That yields 1. 1 times negative I is negative 1I, which is just negative I. Negative I times 1 is negative 1I again, which is just negative I. And then negative I times negative I. Minus times minus is plus. I times I is I square. Okay? And we don't want to forget 1 minus I here. Now let's reduce this. This reduces to 1 minus. So we have, this is 1I. Negative 1I minus 1I is going to be negative 2I, okay? Plus I squared times 1 minus I. Now, can we reduce this I right here? The answer is yes, because its power is greater than 1. So what is I squared? I squared is negative 1, okay? So we have 1 minus 2I plus I squared becomes negative 1. Okay, and then times 1 minus I. Let's go ahead and simplify that. We have 1 minus 2I minus 1 times 1 minus I. Now, 1 minus 1 is just 0, so we're going to have negative 2I multiplied by 1 minus I. To finish this off, we'll just simply distribute negative 2I to 1 and negative I. Negative 2I times 1 is negative 2I. Negative 2I times negative I, minus times minus yields a plus. And then we have 2I squared. We have another I squared scenario which has to be reduced. So this is going to become negative 2I plus 2 times I becomes negative 1. Okay? And then your final answer, just multiply negative 2 positive 2 and negative 1. That gives you negative 2 minus 2i. And that is your final answer. Okay, let's consider question 26, the first part. It reads, an orange juice processing plant receives a truckload of oranges. The quality control team randomly chooses 3 pills of oranges, each containing 50 oranges from the truckload. Identify the sample and population in the given scenario. Okay, so let's start with the sample. The sample is basically what you are selecting. Okay, so what did the quality control team select? What did they choose? They chose pills of oranges. Okay, so the sample space is going to be pills of oranges. That's your sample space. Okay, and then our population basically represents where this sample space was selected from. Where did they select the pills of oranges from? They were selected from the truckload. Okay, so the population is the truckload of oranges. So there goes your sample and population in this particular scenario. Alright, the second part is state one conclusion that the quality control team could make about the population if 5% of the sample was found unsatisfactory. Okay, so all we just have to do is state this observation that they made. 5% of the sample was unsatisfactory as a probability type statement. Okay, so there are different ways you can write it. One way you can express this, or one conclusion you can write, is that there is a strong probability that what? Just state the information that they found out here, that about 5% of all the oranges in the truckload are unsatisfactory. That is based on the sample space. So the assumption is that the sample space is going to mirror exactly what will happen when you consider the entire population. Alright? Alright, let's take a look at question 27. It says, using the unit circle below, explain why cosecant theta is 1 over y. Okay, so first of all, we're going to make use of our identities. Okay, so from the quotient identities, reciprocal actually, from reciprocal identities, what do we know? We know that there's a relationship between cosecant and sine. We know that cosecant theta is the reciprocal of sine theta. Okay, so let's call this equation number 1. Alright, now what do we know concerning the unit circle and sine and cosine? From the unit circle, we also know what? We also know that sine theta is the y coordinate. Okay, so sine is y and cosine is x. Okay, so what we're going to do now is just make a simple substitution. So if we substitute y for sine theta in 1, because from 2 we know that y is equal to sine theta. We have what equation? We have the equation cosecant theta equals 1 over y. And that's basically the end of the story. Alright, let's take a look at question 28. It says the function m of t represents the mass of radium over time t in years. M of t equals 100 e to the ln of 1 half t over 1590. Question, determine if m of t represents growth or decay. Explain your reasoning. Okay, so let's start by indicating what exponential growth and decay models are. Okay, so exponential growth functions are of the form, let's say f of t equals a sub 0 e to the rt, right, where the growth rate is positive. Okay, so that's the first thing to note. And on the flip side, exponential decay functions are of the form, what form are they in? They are of the form f of t equals a sub 0 e to the negative rt. Okay, so where the growth rate is negative. Okay, the growth rate is negative. That is why we have the negative RT component. Okay, so the sign of the exponent right here, the sign of the ln 1 half over 1590 will tell us if this is a growth or decay function. Okay, so we consider the sign of ln 1 half over 1590. So what is this equal to? ln 1 half over 1590. What we're going to do is input that into our calculators and just look at what the sign is. So the natural logarithm of 1 over 2 divided by 1590 is negative 4. So negative 4.3594 times 10 to the negative 4. Okay, so what can we conclude based on this? We can conclude that the growth rate is negative, which indicates that we have an exponential decay function. Okay, so since the coefficient of t, which is r, is negative, m of t represents an exponential decay function. Okay, that negative means that it keeps decreasing at an ever increasing rate. Alright, let's consider question 29. It says, on the grid below, sketch a cubic polynomial whose zeros are 1, 3, and negative 2. Okay, so the zeros are basically the x-intercepts. Okay, so let's recollect that. We want to recall that the zeros are the x-intercepts? So what this problem is asking us to do is basically sketch a cubic function with these x-intercepts. Okay. All right. So there goes my x and my y axis. I'm gonna go ahead and draw my. Let's calibrate it first. So this is positive 1, 2, positive 3, and then this is negative 1, negative 2. That should be enough. Okay, so we need to have zeros where? We need a 0 at negative 2. We need another 0 at 1 and another 0 at 3. Okay? Whatever cubic function I'm drawing must have at most 2 terms since um, we have 3 zeros. Okay, at most 2 terms because the number of terms is always 1 less than the degree, the number of zeros that the polynomial function has. Okay, so you can draw it any way you want. Make sure that it's a function. It passes the vertical line test. So let's draw. There are many ways you can draw this. Okay, so you can draw it going down like this and going up, and then it has to come down and it has to cut this intercept. Remember, we don't have any double roots here, or it wasn't indicated that we have any multiplicities. So we assume that it's just once. Well, it's cubic also, so they can't have any multiplicity. So it has to cut these 3 zeros because it's classified as a cubic polynomial, and the 3 zeros are different. So you have to ensure that you cut it, and they cut this, and they cut this. And this is a possible solution. There are infinitely many ways you can draw a polynomial that satisfies this condition. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial or the anything on the math Regents in general, just place your questions in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. We update math tutorials to our YouTube page on a consistent basis. Do visit our website for more tools to help you do well. We have a lot of formulas there, tips, tricks, and tools to help you succeed. Thanks again for watching, and have a wonderful day. Goodbye.